Okay. We're going to talk about parallel lines.
Okay.
And first off, let's just talk about solving a system of equations. Just kind of a good review of Algebra 1. So don't worry about number 2. That's kind of a weird question. I don't really understand it. But if we look at number 1, how'd you go about solving that?
Like I'm graphing that.
Actually, hold on. Let me read the question more carefully. If you were to graph, will these be parallel? Okay, I didn't read the question carefully. The answer is yes, they would be parallel. That's because if I get y by itself here, no, I lied. They won't be parallel.
Yeah, because aren't the slopes like different?
Correct. Yeah, you have negative 3x. Yeah, so the slopes are different, so they'll touch, meaning they're not parallel. So, um, okay, so now let's talk about parallel lines, right? Okay. So yeah, essentially these are lines that are on the same plane but never touch. So look at M and N, those are parallel.
Yeah.
M and Q, sorry, M and K are skew. I'm just fumbling my letters and words today. M and Q don't touch, but are not on the same plane. So we call them skew. It's kind of like if you have like these two pencils here. So those are parallel, right?
Yeah.
Then that would be skew. They're not touching, but they're not on the same plane. And of course, if they touch, they're on the same plane and they're touching. Planes are parallel if they don't touch. So let's go through these questions here. Think of each segment of the figure as part of a line. Which line or plane in the figure appears to fit the description? So lines parallel to CD and contain the point A. Well, definitely that's AB. That's pretty obvious.
Would HG be parallel?
Yeah, but it has to go through A though. HG
Oh,
does not go through A. Now to be skewed to CD and go through point A, I would say AG
okay.
because it's on the same plane as CD. Perpendicular to CD and containing point A, I'd say AD. Uh, Plane parallel to EFG and containing the point A. Um, so I say plane ABCD. And usually you just need 3 points to define a plane, but I'll just say them all. So, yep. Now, um, parallel postulate, there's exactly one line through a point P parallel to line L. So, yeah, I mean, there's only one way that could happen, right? Now I could draw infinite lines parallel to line L, but to go through point P and be parallel at the same time, there's only one such line that could happen. And likewise with a perpendicular line. To go through point P and be perpendicular to line L, only one such line. Um, Name a pair of parallel lines. So AC and LN.
Okay. Perpendicular would
Yeah, what do you think? What would be perpendicular?
HIBD.
Yeah,
Or
I agree. Yep, yep. How about DH? Is DH perpendicular to LM?
where was it again?
DH and LM.
Yeah.
If our extended, yeah, good touch. Yeah, 100%. Yeah. Okay. Um, a line intersects two or more coplanar lines. Yeah, we call it the transversal. So we have and the two lines don't have to be parallel, but if I have two lines and a line that goes through both lines is going to be called transversal. So when we start dealing with parallel lines, and we start dealing with all the different theorems involved with them, we call this the transversal, just a color code. So in red, that's my transversal. Now corresponding angles, 2 and 6 are called corresponding angles. I don't know, just because they seem to correspond to each other. They have corresponding positions, I suppose. Alternate interior, they alternate on each side. They're sorry, opposite sides of the transversal, but they're inside the two lines. Alternate exterior, again, they alternate, but they're outside. Consecutive interior, they're on the same side, but they're inside the two lines.
Okay.
So in this case, corresponding angles, I could say angles 1 and 5. I could also say angles 2 and 6. What else can I say?
Uh, 3 and 7
Uh-huh.
and 4 and 8.
Yep, 100%. You got it. Good. Okay. Now, alternate interior, I could say 2 and 7. And what else?
Does that work?
And 4 and 5.
Yeah.
4 and 5, right. Mhm. Alternate exterior, I could say 1 and 8,
And 3 and 6.
3 and 6. And then consecutive interior, I could say 2 and 5 or 4 and 7. So that covers that lesson. So does that terminology make sense and all the labels? That's going to be very important for some stuff we do later on. Now, what if the lines are parallel? So coming to the warm up again, 1 and 5 are corresponding, 2 and 7 are alternate exterior. But what if the lines were parallel? And we usually show that by these little symbols here. You know, I kind of do these little arrows that kind of show that the lines are parallel. So 2 and 6 would be identical, 4 and 5 would be identical, 1 and 8 would be identical, but 3 and 5 would add up to 180. That's because if I put angle 3 here, I know angle 3 and 4 add up to 180. And since angle 4 and 5 are the same, if I substitute, I expect the same thing to happen.
Okay.
Yeah, so that's what's happened there. So here, let's identify the angles that are equal to 120. Well, definitely angle 5.
Yeah.
Definitely angle 8 because alternate exterior, and plus 5 and 8 are opposite of each other. And definitely
4.
angle 4 because it's vertical. Yep. Mhm. And 4 and 8 do correspond to each other as well. Yep. Okay. Go and give these a shot. You're going to be solving for X. I need to use the rest one. I'll be right back.
Okay. Ah. Hmm.
X would not be 65. It'd be 60.
Oh yeah, yeah.
Yeah, okay. Careful there. Okay, good. Good. I agree. Okay. Yeah, 1 and 2 are obviously the same. So that's just because they're alternate exterior. Sorry, alternate interior. If you expand them. Yeah, so all's good there. Okay, let's move on to the next one. So now we know what to expect here. We know X is going to be 32. Let's not worry about that one.
What are they even asking on number two?
I don't know. Don't worry about it. It's so dumb. I found this online somewhere. It's stupid. So again, so now if we want to prove that they're parallel, I mean, I'm not sure how that's different. I guess we were told that these are parallel. So I guess if you want to prove that parallel, I mean, I don't see how it's really any different, but obviously X here would be 20. Here, that's gonna be 121. I think be Y would be 23 here. Yeah. Um, is it enough information to conclude that M is parallel to N? Yeah. So that's 105. And those are the same. So yeah, that's a yes. Um, yeah, so consecutive interior angles. Yeah, obviously if those out to 180 are supplementary, you have parallel lines. We're gonna be doing some proofs, I think, in a little bit. Yep, those are gonna be parallel if the alternate interior angles are the same. If the alternate exterior angles are the same, they're gonna be parallel. So it's kind of a repeat. Um, so that's a yes. That's a yes. If it's out to 180, I mean they're both 90, that's fine, but
Yeah.
if that were 80 and that were like 100, that wouldn't necessarily, no. The answer is no. Also, if two lines are parallel to the same line, then those two lines themselves will also be parallel. So if P is parallel to Q, and Q is parallel to R, then P is parallel to R. And then here, obviously we have, yeah, how do I know the top stripe is parallel to the bottom stripe? That's because of the transitive property. Yeah, one's parallel to two, two is parallel to three, and so forth. Three to four, four to five. So 1 to 13 would be parallel. It's kind of a stupid one. Um, Here we're talking about slope. Good review of algebra one. Remember, two lines of the same slope are parallel,
Yeah.
and perpendicular have to be negative reciprocal slopes. So here I go up 2 over 2. So slope of 1. Here I go up 4 over 2.
Yeah.
Here I go down 2, right. Oh, sorry. Down 4. I have to look at scale.
Yes.
And 1, 2, 3, 4. So it's negative 1/2, negative 4/8. Or negative 1/2. Okay. Obviously, yes, yes, no. You don't have to calculate the slopes. I think that's pretty obvious. Um, this is probably a no. So that's down 2. 1, 2, 3, 4. So that's negative 1/2. 1, 2, 3, 2 is 3/2. Yeah, those are not negative reciprocals of each other. But here, down 1, right 4, up 4, right 1. So those are negative reciprocals. That's a yes. Then here, that's the slope of 0, and it's undefined. So that's yes also, because if you do 1 over 0, that's undefined.
Wait, why is it zero?
Oh, for the horizontal line, because there's no run. Sorry, there's no rise.
Oh yeah, okay.
Yeah,
So
like
zero over something.
yeah, like if I take the difference in y's is 0, difference x is whatever. But here for the vertical line, the difference is in y's is whatever, but different x is 0. So when there's 0, right? So now we're gonna actually do some calculations. Don't think we necessarily have to do all these. Maybe we could do the odds. So if I find the slope of this one here, 2 over 2 is 1. So those would be perpendicular. Those are negative reciprocals of each other. If I do this next one here, 2 minus 3, or negative 5 minus negative 2, three minus 1. Yeah, that's neither. Then last over 15. Yeah, so I get parallel lines for that. that one. So did those make sense?
Yeah.
Yeah, so just kind of go through the calculations and all's good there. That's the last one here. And let me make sure it's consistent with the textbook. Yeah, for the most part. But we should probably do some proofs. Yeah. So lastly, writing equations of lines. Should be pretty easy. Y equals mx plus b, we know this. So y equals negative 2x plus 3. Y equals x plus 1. Y equals half x minus 5. Here, up 3, right 3. To get b. Here, I mean, these are should be pretty obvious what to do. Sometimes y-intercept may not. Well, actually, y-intercept I think is obvious for each of these. Why don't you go do 5 through 10 right now? Writing the equations of each. Actually, just do the odds. Because it's gonna be a bit repetitive. Yeah, we'll just have you write the equations of each of those lines.
Oh, I accidentally didn't even.
What was that, sorry?
I
That's
ac
okay. That's okay.
Okay.
Okay, cool. Yeah, these are pretty obvious. You could probably we could probably use point slope form, which is this. If you want to get in slope intercept form, you just isolate y. It's not that hard. We're here. And slope intercept form is kind of more popular form to go with. Actually, just out of curiosity, so you're doing geometry next year, right?
Yeah.
So what would you do as a junior then?
Algebra 2 trig.
And then you would do pre-calculus to senior rate.
Yeah,
Got it. Good. I was just curious about your math track.
that's just the normal.
Yeah, no, I get it. I was just curious. Um, yeah, because I wound up doing algebra 2 trig as a freshman, then geometry honors as a sophomore, then pre-calculus honors as a junior, then calculus. And your dad, I think, was on the same track too. So it's I know it's changed so much over the years. So
Yeah.
anyhow, so yes, that's what we got. So does that make sense? So I got those.
Yeah.
Yeah, and I'm using point slope forms, you know. And then this is with parallel and perpendicular lines. I'll do 14, 17, I'll have you do 15, 16, 18. So if you want to be parallel to the line and pass through that given point, you would just say this: y minus 3 equals 2 parentheses x minus 1. That's all.
So they just write. I just write the equation.
I'm sorry, say again.
You just want me to write the point slope form equation.
Exactly right. And then for 17, you do y minus 2 so yeah, just going to do the other ones here. So if it's perpendicular, you have to say positive 3, the slope, right?
Oh, those are perpendicular.
Yeah, so it's going to be 3 instead of negative 1/3.
Okay, so that's is that it?
Yeah, but you got to make it 3 also, not negative 1/3. Not positive, not positive 1/3. It has to be 3 parentheses x plus 3.
Oh, okay.
Right. Cool. All right, so that was good. Let's talk a little bit about actually let's go to your work because you did upload it. So you have some questions. Hey, thank you for doing that. Now you know how.
Yeah.
Google Drive can be really slow soon. I think they do it on purpose to make you use Google Meets, to be honest. I don't know. Maybe I should try Google Meets, see what happens. um okay. Wow, your work's really neat.
It got progressively more. You see those
Okay.
question marks?
Yeah. Okay.
And then number 17 on the quiz.
Yeah. I'm not 100% sure. So it's page 103, okay. You know what page numbers that would be?
Um, I think it's the I, mm,
Um,
I think it's the third one, like the third assignment, 111, I think. Yeah, 111, 3 to 5.
Okay, okay. So number 11, all right. See here.
You can just go here and then just go to the person.
Oh, thanks. So are these problems here, number 11?
Number 11. No, I did that. Wait. 10, 11.
I'm still confused. Was it a proof?
I don't remember. I did that. I think I did this like last Friday.
Looks
Uh,
like it would be a proof.
maybe it was.
Yeah, it's the way it's being set up here. Was it the practice test? Maybe that's what it was.
Oh yeah, maybe.
I think so actually. Um,
Oh yeah, it was. It was.
yeah. So once okay, so let's go 119 actually. Yeah, because it all that makes sense because I had units for other places, so not that many units. Okay, see here. See. Doesn't make any sense. It's not a proof. Maybe in the chapter review. I'm confused. I don't know which problem you're doing.
I think it was that problem, but I don't know why I drew 1, 2, 3, 4, 5.
I don't know either.
But I think it was on this list.
Yeah,
Oh wait.
I don't know.
I think it was not relevant, but I don't remember where I put.
Okay, right. Oh, right. The if then the converse inverse. Oh, I see what you're saying. Okay, so you're
Oh
okay.
yeah, 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 which is
Okay,
that?
so it's not okay. I understand now. I understand. Okay, I see why you put five because five different things we asked about. Okay, here's what I do. A relation that pairs each input with exactly one output is a function. So you could say if a relation um pairs with each input, then there's exactly one output. Or sorry, let me rephrase that. If a relation pairs each input with exactly one output, then it is a function. So that's what you could say. If a relation pairs each input with exactly one output, then it is a function. That's an if then statement. Okay. Now, as the converse, you just reverse it. If it is a function, then the relation pairs each input with exactly one output. That would be the converse. But sorry, let me take it back. I think you just reverse it. Hold on, or you negate. Great, it's not converse shoes. Yeah, you just switch it. Okay, I had that right. Inverse is when you negate. Got it. Okay. For some reason, I always confused with. I don't know why. So you're gonna say if a relation is a function, then each input pairs with exactly one output. That's how you write the converse. Then
Okay.
the inverse would be if a relation does not pair each input with exactly one output, then it is not a function. The contrapositives and you do both. You reverse and you negate. So if a relation is not a function, then each input does not pair with exactly one output. And always a contrapositive will be true compared to the original. I mean, I do think the converse and inverse are true still, but always guarantee the contrapositive will always be logically equivalent to the original. And then lastly is a biconditional, like going back and forth. You can say a relation is a function if and only if, it's going both ways, if each input pairs exactly with just one output. So that's what happens.
Okay. I just really I knew like what I was supposed to do. I just didn't know like what it like wanted me to like base it off of. I didn't know what like it was saying.
Oh, I'm sorry, say again.
I didn't know like what it was saying.
Oh God, but that's what they want. Okay, so that's what's happening there. So I think we're good there, that one. Now 17. Yeah, you want to write a proof.
Also, what is this? What does this symbol mean?
Congruent. Right here.
Yeah.
This means equals. Congruent. This
Well, why is there like a little thing there?
just congruent means it has the same measure and the same shape, but if it has the same measure, of course it's gonna have the same shape. That's all it means.
Oh, okay.
Yeah, it's just a fancy thing. Don't worry about it. So you want to prove that 2 and 3 are, no, sorry, given that 2 and 3 are the same, and TV bisects UTW. Okay, so yeah, so here's the deal. You're gonna say, I'm glad I'm recording this, so I'm recording the reference here. Angle 2 is congruent to angle 3, and at the same time, I'll say TV. Sometimes you can say each given separately, but I'll just kind of do it all at once. Then I'm going to say angle 1 equals angle 2. And that's the definition of angle bisector. Then I'm going to say that angle 1 equals, yeah, I think that's it actually. Yeah, then I say angle 1 is congruent to angle 3. That's a substitution. Yeah, that's all.
Oh.
Yeah, that's actually a pretty simple one. Yeah, that's all. Just three-step proof. So, because it's kind of the beginnings of proofs, So let's take a look at the textbook again. Oh, we are at a textbook, sorry. So proofs of parallel lines. Like here, total 4 and 5 are the same. You want to prove that G is parallel to H. Well, I mean, obviously 4 is 5, so I already know that. But I could say 1 and 4 are the same. Then 1 and 5 are the same. And if you have corresponding angles, then it's parallel. But I mean, it's kind of a stupid one. Let's do one that's a little more. Yeah, like 35 is a good one, right? So you could for 35, what you could say here is that okay? 1 and 2 are the same, 3 and 4 are the same. Well, I know 2 and 3 are the same, right?
Yeah.
So guess what?
That means the triangles are the same, right?
So then angle 1, well, yeah, but we'll say this angle. Well, actually, I don't know for sure if triangles are the same, but I know angle 1 will be congruent to angle 3. And then angle 1 will be congruent to angle 4. And when that happens, those are alternate interior angles. Then I can say AB is parallel to CD, and that's because two lines are parallel if alternate interior angles are congruent.
Okay. It's just
Yeah. So yeah. Um, that's kind of but I think what we don't have to go too heavy into proofs. I think it's more the conceptual stuff I want
and then
to.
also like before our next meeting on the 29th, should I do my chemistry homework?
Yes, 100%.
Yeah.
And I'll give you a little bit of math to do as well.
Yep.
Because now's a good time to. And by when do you go back to school?
So I think we'll do the 29th, the 5th, and then I go back on the 12th, which is a Tuesday. So no.
Got it. Okay, so let me scratch the 12. Actually, I can't do 12 because I have to be back at work. But
But probably the 19th because I'll probably have like a review test by then.
let me cancel the 12th here. Okay, but 19th. Okay. Um, now I have that open. Well, actually, I wasn't even available anyway at that time. So okay, that's kind of weird. Anyhow, okay, cool. I think we're all good there. I do need to get going because I have to be back at my house in a few minutes. But I think we covered everything I wanted to cover, which is good.
Yeah.
So work on the chemistry right now. Let me get the math homework to you. I'll try to get to you later tonight. So at least you have that as well. But start working on the chemistry.
Okay.
Yeah, that's what I do. So and we'll meet next week.
Okay. Thank you.
Cool. I'll see you later.
Bye.
Bye.